Hello everyone, welcome back to our channel Math and Chemistry. So my dear friends and students, in this video lecture we will continue our previous series that we have started on previous year questions of quantum chemistry that came in NET and GATE exam. So in the previous video we have discussed a few questions, 5 to 6 questions from quantum chemistry, and in this video lecture we will continue with our same session. So let's see the question. Next question. This question also came in GATE exam. So in this video, I have selected questions on particle in one-dimensional box, two-dimensional, and three-dimensional box, and a few questions are on commutator operator. Okay, so let's see the first question of this second video. Question is the first excited state wave function for a particle in 1D box that spans from -a to +a is, okay, so 4 options are given to us. The question is the first excited state wave function. So particle is moving in one-dimensional box. Okay, we know that the wave function for particle in one-dimensional box is given by the expression equals to √2 by L sine n pi x over L. This is a general wave function for nth state. Okay, but here it is given the particle is present in the box that spans from -a to a. Okay, suppose this is the box having length from -a to +a. That means the total length of the box is 2a. Okay, so here length L is 2a, right? And it is mentioned first excited state. So what is the meaning of first excited state? You know, this is the ground state, and ground state considered as n equals to 1, means n equals to 1 corresponds to ground state and n is equal to 2 corresponds to first excited state. So this is our first excited state. So that means n value equals to 2. So students, in this wave function, we will use the length equals to 2a, sine n is 2 pi x over L, again 2a. So 2 will be cancelled out and you will be left with this expression 1 over a sine pi x over a. Okay, so we can check our options, which option is correct according to our answer. So option B is correct. Okay, we can easily reject option A and option C. Why? Because it is having cos of angle pi x over a. So you know, in the wave function it includes sine. Okay, so option A and C is incorrect and option B is correct. Now let's move to the next question. So question statement is, consider a particle of mass m which is moving in 1D box under potential V equals to 0. Length of the box is a and V equals to infinity outside the box. You know, if you know the little bit information about particle in one-dimensional box, so here we consider that your electron particle is moving inside the box and here potential energy is 0, means electron is moving freely, it is not under any external force, and out of the box potential energy is infinite, and at the boundaries also, okay, these potential is infinite. It means the electron cannot go outside the box. Okay, so these walls are considered as the potential barrier that electron cannot cross. So it is saying that when the particle is in its lowest energy state, the average momentum of the particle is, okay. So students, this question, to solve this question, we need to use the expectation value of the momentum. We need to use a formula. Okay, so how to find out the average momentum px of the particle? So we have the formula to find out the average value for any observable quantity in the quantum mechanics, and formula is integration of psi, your operator, that is momentum operator, psi dx. Okay, so here we take the limits. Particle is moving in the box and whose length is from 0 to a. Okay, so here we will put 0 to a. So here px is the momentum operator. You know the expression. Okay, you should know the expression, that is minus iota h cross curl by curl x. And you should have the information about the wave function also. So the wave function for particle in 1D box, it is under root 2 by a sine n pi x over L. So here in the statement, it is saying the particle is ground state. Ground state means n equals to 1. So here I'm not writing n. I'm writing pi x over e. This is the wave function. Okay, now we will solve it. To solve this question, let me take another screen. Okay, so here we'll solve. Yes. So we are given, we know the wave function. It is under root 2 by a sine pi x over a. Okay, so we need to find px, average value of momentum. So for that, we will use this formula psi px psi dx, and length is from, and limits from 0 to a. Okay, so it is a bit lengthy. Okay, so here we will substitute the values or the expressions for every parameter. This is psi, and px we know minus iota h cross curl by curl x. Again, wave function 2 by a sine pi x over a. Okay, here we write dx. So students, here we have the differential operator. So first we need to differentiate this wave function. Okay, so before doing the difference integration and differentiation, let's take out all the constant terms out of the integration sign. So under root 2 by a, we have 2 times, right? And this is minus iota h cross. This is also constant. This is also constant. So I'm taking it out from the integration sign, minus iota h cross. And under 2 by a, it's 2 times. So I'm writing 2 by a only. Inside the integration sign, we are left with sine pi x over a, and the differentiation of sine pi x over a. Okay. Now the differentiation of sine x, we know it is cos x. Okay. So we will differentiate it. It is cos pi x over a. Again, differentiation of the angle, which will be pi over a. Okay, so again it is constant, so I will write it out of the integration sign. So we have sine pi x over a cos pi x over a. Okay, so students, here what we will do, here we can make a trigonometric formula, that is 2 sine theta cos theta, which is equal to sine 2 theta. Okay, so in here also we have the product of sine theta and cos theta. So product of sine theta and cos theta can be written as sine theta by 2. Okay, this 2 will go here. So we can write this product of sine theta and cos theta. So here I can write it as sine 2 theta by 2. Okay, that 2 I'm writing outside. This is 2 theta. Theta means pi x over e. Right? Now we will integrate the term that is inside the integration sign. Let me write the terms first. Okay. Now we will integrate. So integration of sine is minus cos 2 pi x over a. Also, here we write the differentiation of the angle, which is pi x over a. And limit is from 0 to a, right? So here we will substitute the limits. My dear friends, I'm writing all these terms. I'm replacing it by some another constant. I'm not writing it again and again. So I'm writing capital A in place of this whole expression. Okay, so here I'm putting the upper limit minus cos 2 pi. अब लिमिट किसके प्लेस पे पुट करते हैं, x की प्लेस पे. So here I will write a upon a minus minus plus cos 0. Okay, so this a will be cancelled out, and here this term is also included in this. Okay, so this a represent this whole term. So here I am left with minus cos 2 pi plus cos 0. You know, cos 2 pi is 1. Okay, so minus 1 plus cos 2 pi is 1 and cos 0 is also 1. So whole answer is 0. Minus 1 plus 1 is 0. Okay, so students, the average value of momentum is equal to 0 for particle in one-dimensional box. Okay, so you can remember also that average value or expectation value of momentum for a particle when it is moving in one-dimensional box, it is 0. Okay, so if you can remember, then there will be no need to solve this whole derivation. Otherwise it will consume. Okay, because for the competitive exam, sometimes we need to remember the results so that we can save our time. Okay, now let's move to the next question. So here, this we have done, option A is correct. So here, option A is correct. Now let's move to the next question. The degeneracy of quantum particle in cubic box having energy 4 times that of lowest energy. So here the question is on the degeneracy. You know, degeneracy. It is the number of energy states having equal energy. Okay, so suppose we have 3 energy levels, and all the 3 energy levels have same energy. So we can say that that state has degeneracy equals to 3. Okay, so degenerate state means the states having equal or same energy. So in the question, they are asking us to find the degeneracy of the quantum particle which is present in the cubical box and whose energy is 4 times that of lowest energy. So first we need to find the lowest energy. You know, in the for a particle in cubical box, you should know the formula. So formula for the energy is n square x plus n square y plus n square z h square over 8m L square. You know, for when the particle is moving in 1D box, then the formula is n square h square over 8ml square. Okay, if the particle is moving in 2D box, then here we write the two quantum numbers along x direction and along y direction. Other terms remain same. Okay, then energy for the 3D box, here we here three terms comes n square x, n y, and n z. These are the quantum number along x, y, z direction. Okay, so we know for 3D box the lowest possible combination of nx, ny, and nz. Okay, means the possible combination of nx, ny, nz, which will give us the lowest energy, it is 111. Okay, so that means the for ground state, the combination of nx, ny, nz is 1, 1, and 1. Means if you put 1, 1, 1, 1 in place of nx, ny, nz, you get the lowest energy. So the energy of the ground state will be 3h square over 8 ml square. Okay, now there is another quantum state having energy 4 times that of lowest energy. So this is this is the lowest energy. Lowest energy. Okay, now the new quantum state. Okay, for the new quantum state, the energy is 4 times of lower energy. Okay, and it will give you 12h squared over 8 ml squared. Now, students, here we will compare this energy of the quantum state with formula of energy of 3D in the 3D box. So here h square over 8 ml square is same, okay, and here n square at the sum of, if you compare this equation with this one, okay, let me mark. If you compare 1 with 2, okay, you will see that the sum of n square y, n square z, it is 12. Okay, so here we need to find the possible combination of nx, ny, and z, so that there's sum of the square of these number gives you 12. Okay, so what is that value that we need to check? If you take like after 1, 1, 1, what is the possible state? 1, 2, 1. Okay, so if you substitute this value, means here, then you will get 1 plus 4 plus 1. Then it will give you 4 plus 2, 6. Then this is not correct combination. Okay, let's see the another. If you substitute 2, 2, 2. So if you find the square and you add it, then you will get 4 plus 4 plus 4. That is 12. Okay, so that means this is the possible combination of nx, ny, and z that will give you 12 after squaring and adding these numbers. That means we have only a single possible combination, 2, 2, 2. No another combination is possible. That means there exists only one state. Okay, because we have only one combination. So there is only a single state. That means the degeneracy of the quantum state of the particle in cubical box is 1, because there is a single state corresponding to energy equal to 12 h square over 8 ml square. Okay, so this is the correct answer. Suppose a student say we have energy equal to 6h square over 8 ml square. Then what will be the degeneracy of this state? Okay, then how you will find it? This is a treat and trial method. You will find the possible combinations for nx, ny, and nz. For 6, you have the combination 1 to 1. Okay, so because some of the square of these numbers will give you 6. But this number can be written in 3 ways. First possible way is 1 to 1. Second possible way you can write in this way also. And third possible way you can write in this way also. 1, 1, 2. So here we have total 3 possible way to write this combination 1 to 1. Okay, that means this represent there are 3 states. Okay, 3 different states having energy equal to 6 h square over 8 ml square. That means the degeneracy equals to 3. So in this way we find the degeneracy. Now let's move to the next question. Students, in this question, please make one correction. Here in place of x squared, it should be x cubed. Okay, so this is one mistake in this question. So the statement is the commutator of this operators is equal to. So student, there is one very good trick to find the answer. Suppose you have x raised to power n and px. You want to find out the commutator. Then there is a formula that it will give you n. First, you will write iota h cross. Okay, iota h cross. n x n minus 1. Okay, this is the best trick to remember to solve this kind of questions. Okay, means if you have two operator, one is position, other is momentum. Okay, and if you have some power over here, then you can compare these two expressions. Here it is giving n equals to 3. So just substitute the value of n here. You will get the answer. So n is equal to 3. Then iota h cross x 3 minus 1. It will give you 3 iota h cross x square. Okay, but if you look at the option, none of the option is matching with our answer. So we need to modify it. You know, h cross is h over 2 pi. Okay, so I'm writing h cross as a h over 2 pi. And one more thing, in the options, if you look at the option, the iota is present in every option. Iota is in the denominator, so I need to remove this iota also. For this, I will multiply and I will divide this whole expression by iota. So I'll get iota square and 3 h x square over 2 pi iota, and you know iota square equals to minus 1. So minus of 3 h x square over 2 pi iota. Now I think we got the answer, which is option A. Okay, so option A is the correct answer. I hope this question is clear. Now I will move to the next question. Yeah, this is the last question of this video. So here, let's read the statement. There is an electron of mass m who is confined to move to 1D box whose length is b. I mean, there is a box, one-dimensional box whose length is b. If it makes a radiative transition from second excited state to ground state. Okay, let's suppose this is the ground state. This is the first excited state. This is the second excited state. You know, ground state corresponds to n equals to 1. First excited state corresponds to n equals to 2. And second excited state corresponds to n equals to 3. Right? This is ground state. This is first excited state. This is second excited state. Right? So there is an electron which makes a radiative transition from second excited state to the ground state. In this way, it makes a radiative emission from higher state to ground state. Then find the frequency of the photon emitted. Okay. Now, first we will find out the energy of the ground state. Energy of ground state means, here I'm writing E1, which corresponds to n equals to 1. Right? So we know the formula, n square h square over 8 ml square. This formula is very, very important to solve the questions for one-dimensional box. So here n equals to 1, you will put 1 here. You will get h square over 8 ml square, which will give you the energy of the ground state. Now let's find the energy of the second excited state, for which n equals to 3. So here you will substitute n equals to 3. You will get 9h square over 8 ml square. Now we will find out the energy difference, that is equal to delta E. Okay, so it will give you 9h square over 8 ml square minus h square over 8 ml square, right? Which will give you 8 h square over 8 ml square. That will be cancelled out. You will get h square over h square over ml square. Now you know it is giving you the energy, change in energy, okay, or the energy required for making the transition. But they are asking you to find the frequency. We know delta E energy is related to frequency by this formula, delta E equals to h nu. Okay, so in place of delta E, we will write h nu, which is equal to h square over ml square. Okay, so from here, 1h will be cancelled out and you are left with nu, that is the frequency, equals to h over m L square. Sorry, here I have written L, but in the question, the length of the box is B. Okay, so in place of L, please write B over here. Okay, please make this correction. Yeah, this is B. Here also B square. So answer is H over MB square. So let's see which option is correct. Option C is correct. Okay, students. So here we have discussed 4 to 5 questions. Here I am ending this video lecture. In the next video, we will discuss the next question from the same topic. I'll choose the particle in one. First, we will complete the quantum chemistry questions on 1D box, 2D box, or 3D box, and from the operators. Okay, then we will jump to the next topic. Thank you so much for watching the video.